Now, most of the time when you guys are coming in to split cells, the hood is already going to be prepared for you. There are a few students that might be coming in early, and if that's the case, sometimes you've got to turn the hood on. If the sash is pulled down, you just want to pull it up to the little indicated areas on the side there that you can see, the little arrows, and turn on the light. When I prepare the hood and I've just turned everything on, I will still go ahead and pull my media and spray it down and wipe everything down, including the hood and of course the snarge glass on the front. I will go ahead and spray everything down and place it in the hood, but know that it's going to take, if you've just opened up that hood, it's going to take about 10 to 15 minutes for that laminar flow to establish a sterile work environment. So you're going to do all this and then you're going to just walk away, go, I don't know, have a snack or a soda. I go ahead and I do spray down everything and put everything in the hood already. And then when I come back, everything is ready to go, and I can just hop right on in there and get going with whatever cell split I have to do. The hood should be up and ready for you when you come in, but I do know it makes a lot of noise, so sometimes it does get shut off. So do know you want to verify the hood is on, and that you wait 10 to 15 minutes if you've had to turn it on yourself. When you're checking your cells, the very first thing that you want to do when you pull them out of the incubator is you want to look at the media. Is it clear and not turbid? In this case, these NIHs, the media looks great. While I'm at it, I'm going to go ahead and check those two flasks that I made where I was doing a sterility check for the media. And both of those, even the one that I maybe thought I might have contaminated, looks good. So both of these look good, which indicates that my media is fine, and that I did not introduce any contamination over the course of making it. So now I've checked that the turbidity of the cells is good. I'm going to just throw them under the scope, and I'm using Floyd here. You're welcome to use Floyd, but you're also welcome to just use the regular microscope. Using Floyd, I turn on the white light and I have to turn it way down, usually somewhere 9 to 10% to get the contrast that I want. And I'm again going to look at a number of areas on the flask. I'm not just going to do one quick peek and then move on and start my split. I want to make sure that what I'm seeing is representative of the entire flask. And if you have properly seeded your cells, hopefully it is. But as I move around to different areas of the flask, I see pretty consistently a 70 to 80% cell population here, which indicates that I really do need to split these today. And so these have recovered very quickly, and they look very healthy and they're growing well. But I also don't want to overdo it with a really harsh split initially. So I'm going to do a pretty easy split on this cell type, and I'm going to pick like a 1-to-3 ratio, and we'll talk about that in a different video. So now I've prepared the hood. The hood has been, blowing for 15 minutes, so I know I've got a sterile work environment. So I bring my cells over, and I'm going to actually set up my trypsinization. And so the first step, I'm going to actually remove the media and wash the cells. And if you recall from one of the lectures about media components, we do have fetal bovine serum in this particular media, and there is certain portions of that serum that will actually inactivate trypsin. So it's really important that we use some of our Hank's buffered saline solution and remove all traces of the media and the serum within the media before we add our trypsin, so that the trypsin can have the most effective mechanism to remove the cells from the surface. And then at the end, we're going to put them all back into the DMEM that I've made in a previous video. So I'm going to go ahead and start this process, and when you're first starting out and it's going to take you a little while to do all of this, I do recommend just allowing the cells to trypsinize in the hood while you are preparing the new flask to sub-clone them into. As you become more proficient, if you want the trypsin to be acting a little bit quicker, you can actually place it at 37 degrees and it will, the trypsin will act a lot more quickly. But there's a danger there because you can over-trypsinize your cells. So when you're first starting out, I really just recommend do the wash, add your trypsin, and just leave it in the hood while you prepare your new flask. And then the cells will be ready by the time your flask is ready. So I've slurped off the old media. I am now going to add, I don't know, about the same amount of the HBSS. I'm working in a slightly larger flask or vessel than you will be working in. So I'm going to add about 15 mils of the HBSS. Your flasks are going to be smaller. You're going to have 5 mils of media, and so you could do 5 mils of the HBSS, and that should be more than sufficient to rinse off any small traces of the serums that could be present on the surface of the cells. So you just add the HBSS, and again, just like when we washed the thawed cells, we're just going to give it a little rocking back and forth to really wash all of those serum components away. And then we're just going to be able to slurp off that amount. Whatever is in there, you're just going to pull off. Any cells that have washed out into that HBSS are probably not healthy cells anyway. And so at this stage, the cells are really growing well. They're very healthy. And so you don't have to worry so much about accidentally removing them from the surface because they're actually adhered pretty significantly, which is why we need to use trypsin. These can be pretty easily over-trypsinized, and so don't let them sit without checking them for more than a couple of minutes. You'll see the whole cell layer kind of slough off in a big old slurry as you move the trypsin around. And so initially when I'm adding the trypsin, you'll see I'm going to add my 1 mil. You guys will be adding 0.5 mils or half a mil. Once I've added the trypsin, I'm going to just rock the vessel back and forth to make sure that I've evenly distributed the trypsin over the entire monolayer of cells. So that's what I'm doing here, is just making sure that I've evenly coated all of the cells with the trypsin. And then I'm going to set this flask aside, and I'm going to prepare my new flasks. And so for this, I'm going to actually prepare 3 flasks. So I'm going to do 3 flasks. I'm going to do a pretty gentle split on these cells for this particular, this is the very first split since they've recovered from freeze. Normally I can do a 1 to 10, even a 1 to 15. But I'm going to be pretty gentle with them on this first split, and I'm going to do a 1 to 3 to make sure everything stays healthy. So I'm just going through here and I am labeling my flask. I am putting, again, my cell type, which is NIH3T3s. I'm putting my initials, and I'm putting today's date, which in this particular case is the 10th of August, 2020. And then I'm also going to put what the split ratio is. And so I'm going to put a 1:3 on each of these cells to indicate that that's what the split ratio was. You'll see in a second here, I am actually going to go in and I'm going to add for one more passage through. I'm going to go back and I'm going to add in the product number and the lot number. You guys won't need to worry about this, but for this split, just because things are going well, I want to just maybe keep that information for one more passage. And so I'm just copying that off of the previous flask. Now this is technically the first split, but after today, the passage number is going to be whatever the passage number is on the flask that I'm splitting plus 1. So this is technically the first split, but the next time I'm going to split, I'm going to add, it's going to be passage number 2. So that's usually indicated by a small p and a number, which indicates the passage number. So this time it's passage 1. Next time it'll be P2 or passage 2. And you can see as you've trypsinized here that most of the cells are free. There's still a few stragglers that are attached to the surface of the flask, But if you let this continue for much longer, you risk potentially lysing the cells, because the trypsin is going to keep chewing even if the cells are free from the surface of the flask. And so you do want to pay attention to how long you have left your cells in trypsin. Those last little stragglers, I'm going to give the flask in a second a nice little smack, and it's going to pull all the remaining cells off of the flask surface. And we're going to be able to move forward in splitting the cells then. So now I'm preparing my flasks. I'm finishing up by just adding an appropriate amount of media. In my case, it's 15 mils per flask. For you guys, any new flask is going to contain 5 mils because you're going to be in a smaller vessel. And so I'm just adding my media for my splits. And then I'm going to come in here and I'm going to actually pull up 5 mils of media. I'm going to do an even split, but I've already got 1 mil, and I just gave a good slap to the flask there. But I already have 1 mil of trypsin in there, so you always want to remember that you have some volume. And in order to inactivate the trypsin, you want to be sure you're adding at least 3 to 4 volumes of media in order to be adding enough serum to inactivate that trypsin. So I have 1 mil of trypsin in there already. I'm going to add 5 mils of media so that I can have an even 2 mils, 2 mils, 2 mils into each of the new flasks. And what I'm doing here is I'm just really washing off that cell surface to get down any cells that might be there. And then I'm going to really spend a minute here and properly titrate the cells so that I am breaking them up into a single cell suspension. And so the way I do that is I actually pull up all the volume, and then I put the end of the pipette against the bottom of the flask, and I just push it out, and it just applies enough force that it actually breaks up any clumps that might be there. And I do that about 3 times, and then I just kind of mix up and down a couple of times to make sure everything is evenly mixed. But that's a really great and easy tip to just really break up those clumps into small individual cell suspensions. And now I'm just going to transfer 2 mils, 2 mils, 2 mils into each of my 3 flasks. And then I'm going to do my, little, as I tighten down the caps, I'm going to do a nice little mix, and then I'm going to put them all down and do my north, south, east, west OCD thing that I do that everyone laughs at. So feel free to laugh along with that if you like. It's completely ingrained in me now, and I have to do it, or I'm sure the cells are going to die, which I know logically is not going to happen. So now the cells have been split. They're in fresh media. They should be very happy. I'm disposing of my old flask in the biohazardous waste. I'm tightening down the caps and giving a good little mix there to each of the individual flasks. And then I'm going to do my north, south, east, and west to just kind of evenly distribute across the entire surface so that my cells set down and have a nice open area to grow into. And then once I'm done with that, I'm going to break down the hood again, as you've seen me do a couple of times now. I do want to make one final note here. We're using vent caps, but always be aware of whatever kind of cap you're using. Because we have vent caps, we don't have to worry about venting the flasks. But if we didn't have vent caps, you would want to do a half turn back so that we could allow air exchange between the cells and the CO2 in the incubator. And that's it. So we're going to break down the hood and have it ready for the next person, and I'm going to place these guys in the incubator.